In this video, we're going to talk about writing string functions, and then we'll talk about some of the built-in functions that C has. Remember, in C, there is no string type. We represent strings with null terminated character arrays. This is a very non-ideal situation, and typically if you're going to be doing a lot of stuff with strings in C, it's probably better to write your own libraries that handle things so that you can deal with string in a safer fashion. One of the problems is that there's no array bounds checking in C. So it's very easy with strings to either overwrite the end of the boundary or leave a bunch of information in memory that maybe you don't want there. So as we go through these functions, keep in mind that these really still aren't ideal. We'll talk about some functions that you should never use, but even the functions that are somewhat safer still have some drawbacks. And we'll discuss some of those as we go through. But the one thing to keep in mind is that strings are null terminated character arrays. There is no bounds checking, so you have to be careful. The way we mark the end of a string is with a null terminator. If that null terminator is outside the bounds of the array, then it will print to the null terminator, not to the end of the array. And another thing to keep in mind when it comes to strings, and this is also true of arrays, that if you declare a string as a character array, you can use the name of the array syntactically like a pointer. But it's important to understand the difference between an array and a pointer. You can treat them the same in the syntax, but the array actually has memory, whereas the pointer it's only a variable that holds an address, and so it's pointing to some other memory. So when you're working with a pointer, you need to make sure you have enough memory allocated there to work with the string. So we'll discuss some of those issues in this video. So right now, this program has a symbolic constant for the length. We've also have a forward declaration for a function, and we will build this function later, but you'll notice that it takes a character array as a parameter. And then I've declared a few strings. So we have string 1 and string 2, which are arrays, and you'll notice I put these two fences around them, these fence variables, and there's nothing special about the word fence, but that's just conceptually what this is. The idea is that before and after string 1 and string 2, I'll have some characters that if something goes wrong with something I do, I'll be able to see it. Now, typically, you won't need this because you shouldn't have problems with the strings, but in some of the examples we do, we'll actually do examples of how you can run into trouble with strings. And so having these two fence strings on the outside will let us see, hey, look, we overwrote this string. We also have two character pointers that we've allocated memory for. Notice again, we've allocated length number of bytes, so they're the same size as our two character arrays. And then I also have these test strings, and this is just to allow us something to copy into memory. Now I've initialized pointer 1 and pointer 2 to be basically empty strings because the first element of those of the memory that this is pointing to is the null terminator. Here we print the size, the value, and the length using string length of each of these functions. I guess one other thing that would be interesting would be to do the address. So let's add that. Okay, so we have some unused variables. That's okay for now. And when we print this out, you can see that the memory for the pointers is in a different place as the memory for the two character arrays, and that's expected. So the character arrays are both 10 bytes. The pointer is 8 bytes because again, it's pointing to a memory location where 10 bytes are allocated, but the variable itself only allocates 8 bytes. Its length is 0, which makes sense because we have a null terminator in the first character. Here the string length is 5, it's HELLO. So it's also important to remember that size of and string length do different things with what they return. Size returns the memory size. String length returns the number of characters before we get to the null terminator. And if I remove that null terminator, then string length could be very long. So the first thing we want to talk about is copying a string. And actually, I'll use printfs to hold the comments here, just so that we're not repeating. There is a C function called strncpy, strcpy. And I'll copy into, actually first, I'm going to use this for pointer 1 and pointer 2. But I want to demonstrate something first. So let me copy into string 2 right now. And I'll copy the characters from the string. And I'll just use programming 220. Now you'll notice that's a longer string than the length of this particular character array. So let's see what happens. So now when I compile and run, so you do notice that we are getting a warning here. It is going to compile, it's going to let us run. So if I compile this, notice string 2 now has programming 220. So the question is, what happens when we do our fences? So let me add code for the fence here. Let's see, I think, yeah, so we have the second one here. And then when I do the copy, I'm going to print those three things again, because my guess is that one of those things is going to not look how you would expect. I just called that fence. So you should notice here that all of a sudden fence 1 is no longer XXXX, it's G220. And the reason is because when I overwrote string 2 with this string copy, all this memory got put, all these characters got put into memory starting at string 2. And immediately after string 2 is fence 1. I have that wrong. It's not fence 1. It's string 1. Okay, so my output here is not correct. Let's see. And I don't want that one. So let me make sure it's correct up here as well. Yeah, it looks like I got string 1 and fence 1 mixed up. Okay, so it's an example of how you have to be careful what your output says, because you can put things in the string that makes, or in the output string that makes your output look weird. Okay, so here we didn't print fence 1 in this case, but you'll notice now string 1 just has G220, which isn't a mistake. It's this G220. So here we have 10 characters. That's the memory for string 2. And then string 1 starts right here. And notice we've overwritten that with our string copy. So that's one of the ways in which string copy is not a good function, and typically you should not use it. So I'll put a note here not to use string copy. So we have a better function, string copy, which takes a string, an input string, and a size. Actually, in this case, let's do test 1. I don't want to get a warning. So if you remember, test 1 is just the digits. 0, 1, 2, and so on. And then I'm going to give it a size, and I'm going to copy len -1 characters. And the reason is I don't want to copy 10 characters because that's the size. I need to leave room for the null terminator. So it looks like I'm copying into string 2 here. I'll eventually change that to pointer, but I wanted to show you how these work first. So now notice we have 1, 2, 3, 4, 5, 6, 7, 8, 9. String copy doesn't put in a null terminator, so we just happen to there just so happened to be a 0 in memory in that 10th character. So to be 100% sure here, I would still want to put a null terminator by hand. Just to be sure. And if I do something like this, where I say string copy linked characters of test1 into string 2, then you'll notice I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. I have 10 characters, but there's no null terminator, so I go right into the memory that string 1 has, looking for that null terminator. So it's important to realize that when these functions start looking for a null terminator, if that null terminator isn't in the array bounds, we're going to have trouble. Just keep that in mind. And now that we've talked about all the warnings, maybe we can actually start doing some actual work. I'm going to delete these just because they don't really make a lot of sense in the long term. Those really were just for purposes of demonstration. Let's string copy into pointer 1. And again, we want to copy length -1 characters. Let's copy the string CSC 220. And for pointer 2, actually, let's go ahead and define one string. Actually, we'll be more specific. We'll say C programming is fun. Instead of copying a string literal here, we'll copy that programming string into pointer. And again, we're subtracting 1 from the length because we don't want to do 10 full bytes. So why doesn't it like that initializer? Because I did a character pointer there. I wanted that just to be a character array. So no warnings. I also didn't print out the strings. So let me do that. So now you can see pointer 1 is CSC220, pointer 2 is C_program. So we cut off the rest of the array basically after 9 characters we copied. Okay, so let's talk about passing a string to a function. And to do this, we're going to define this function here. So we already have the forward declaration. We have a string function in memory. In fact, let's go ahead and borrow this print statement. And I'll just change these names. So here, this is going to take a string as a parameter, and it's going to print the address, the size, the length, and then it'll print the string. And now that pointer 1 and 2 have values, we can use those pointers as well. Now to pass a string to a function, I'm going to pass a character array, and I'm going to pass a pointer to a string. To do that, all I need to do is pass the name of either the array or the pointer variable to my function. So let's see how that works. So you notice I get a warning here, and we're going to fix that, but let's ignore it for now because we are going to fix it in a moment. This is causing some confusion on the output. Let me put a new line there. So you'll notice string 1, its address doesn't change. So even though we're passing in an array, it's not copying and making a new local array. We're getting a pointer to that original location. Its size is 8. Now that should surprise you because the size is different than it was here at 10. And the reason is it's a pointer now. It's no longer an array. That array name gets passed in, but we can treat it like a pointer inside the function. The string length is still the same. The value is still the same. And with pointer, you'll notice that the pointer output is almost identical to what we saw before. And the reason is it already was a pointer, so the size never changed. The length of the string for either of them doesn't change, but again, that array gets passed essentially as a pointer. And if you look at that warning we got, it says size up on an array function parameter will return size of character pointer. So we really don't want that in our function because it can be confusing. So I'm going to take that call out, and that should give us nice clean output from our compilation statement, and it does. Okay, so suppose we want to compare two strings. So the function to do that is going to be, and you'll notice there's an n there, strncmp. N usually means that there's a length parameter. A lot of the functions that we're going to talk about from here on out, very similar to strncpy, have a version that doesn't have that n in the middle, that doesn't take a length, and then it's just depending on you passing in the correct length. It's going to work until it gets to a null terminator. It's always better just to always put the length in there, though, just to make sure that you're doing that some limited amount of balance checking. So we're going to, from here on out, we're only going to use the n versions. Okay, so I'm going to compare string 1 with hello. And I'm going to check to see, does that equal 0? If it does, then I'm going to print that they're the same through those characters. Otherwise, I'm going to print that they are different. Let me do another example like that. And we'll do it with, I'll put an exclamation point there. And so, whoops. So one thing you have to be careful of is you want to make sure that your string that you're printing, or the printf string, it has the correct information in it so that the output's not confusing. There we go. So hello and hello are the same through 10 characters. Now you may say, wait, hold on a second. They are different because, after 10 characters, there's only 5 characters. And the reason is that comparison stops as soon as both of them have a null terminator. So after 5 characters are the same, then we have the null terminator, so we're done. They're equal after that. Here, hello and hello are different through 10 characters because there's an exclamation point here. But if I just do through 5 characters, and so let me change the output so it's a little more clear. Now, since I've limited the length, Notice they are the same through 5 characters. And again, I need to make sure I put that exclamation point there. So you can see this is how string compare works. I can compare the entire string or just a portion of the string. I can also use string compare to do actual ordering. So if it's greater than 0, that means that so we'll do before and after, and I'm missing a parentheses here. And then let's do the comparison in the other direction as well. So here we'll do string 2 first and string 1, and then that should give us an indication that in either direction this comparison works the way we would expect. So hello world is after world, or hello is after world, and world is before hello. Now that's a little interesting. Because I didn't change that here. Wait, no, that's correct. It looks like I have the direction of this backwards. It should be less than, because if string 1 is before string 2, then I'll get something less than 0. And that's the case here as well. So I think if I do this, I should get the correct output. And you see hello is before world, world is after hello. That is what I expect. I can also concatenate strings. So here I'm going to append 3 characters to the end of strncat, or string 1. And actually, since strnccat overwrites the null terminator, let me add 4 characters here just to make sure we get the null terminator from the string that I'm adding. And then I can also do this. And actually, to be clear, I don't want to make it sound like it's doing this automatically. It's doing that null terminator because that's the 4th character there. So now let's grab the print from those 2. So in 84 we have a bug. Yeah, no semicolon at the end of that line. So you can see we have longer strings than we had before. One thing to keep in mind, even though we're using in here, the size of the string is going to be the length of the string will be the length of this string plus the minimum of this string length and this value here. So we're adding characters to the string. We need to make sure that our target string has room for that. Now you may wonder, how do I create strings? Sometimes maybe you want to put things in the middle of strings or modify values of strings. Let's say you want to replace every number in a string with the word it represents. So instead of the digit 1, you would put the word 1. Well, that's going to make a bigger string, and you would need to think about how you want to do that. Now, you could go through a bunch of allocating bigger memory and moving things around. That gets really tricky. So the most straightforward way to create a new string is to use the sprintf function. So before I do that, I want to define a new character array. And you could either use a character array, or of course you could also just allocate some memory. But I'm going to make a character array char my string, and I'll do 100 characters. And you want to make sure, just like anytime you're working with strings, you need to make sure that that is going to be big enough for whatever you're going to do with it. Now, sprintf works exactly like printf, except the first parameter is a string. That works just like printf. So if I printf like this, you'll see that that string is hello world. But what's really nice about sprintf is that I can do more complicated strings. I could say something like, let's say I want to print an ordered pair. So here it's 12 and -4. And just like with printf, those control sequences will get replaced. This is identical to printf, except instead of writing to output, I'm printing to a string. You'll notice it doesn't matter how big that string is, it'll figure out, or how many characters you need, the sprintf will figure that out. So let's say I want to write a mathematical term out. So I would have some number, and let's say that that could be a float, and we'll do 2 decimal points. And a variable, let's call the variable x, and let's raise that to some power, and we'll say the power has to be a digit. So we'll do a floating point number, and we'll do a decimal. So let's compile that. That should be a decimal point, not a comma. I have a bunch of garbage there. Yeah, that was not good. Okay, so this should be correct here. And you'll notice I didn't print that out. So when I compile this, that gives me nicely formatted output. Except I put the .2 on the wrong side. Much better. So you can have whatever you want in your sprintf. It works just like printf. So anything you can printf, you can myprintf or sprintf. So let's say I want to do just a big list of values. I'll do a number. I'll do a character. I'll do a pointer. I'll do a string. And I'll do a number. So I'll do 10. I'll do a character. I'll do a pointer. I'll use pointer 1 from before. The string, I'll use pointer 1, whatever that's still pointing to, and I'll do a negative number here at the end. And when I write that, notice I get all of this stuff in my string. So this is really useful for any time you want to print a string that has some variable length data in it. Yeah, you could go through and figure out, okay, I want to put, -30, or let's say I want to put an integer into a string. Well, let's see, is it negative? So then I'll put a minus sign at the beginning and then convert all the digits. That gets to be a lot of trouble. It's much easier just to use sprintf, because then you can write exactly what that string is. The key is just make sure you have enough memory available for you.